2, the bases. What are we going to do to the 5 and the 2? Thank you. We're going to multiply them 5 times 2 because those are the big numbers. And then Malak J, I have the same bases of x. So when we're multiplying the x's, what are we going to do to the exponents when we multiply the x's?
I think we subtract them.
Okay. So when we multiply, this is how I remember it. When we multiply, all right. Multiplying and then adding, they go together because they're increasing, okay? Dividing and subtracting go together because those two, how I remember it is those are my least favorite. So those two go together. So really we're going to be adding the 2 and the -5 when we're multiplying. So 2 plus -5. And then here the y, same idea. We have the 4 and the 7. So we're going to add those two. So then we get 10 x to the -3 and then y to the 11th. So Ibrahim, what's the only thing we have to move? We have a negative exponent. What is that negative exponent attached to?
Me?
Yep.
Oh, you have to bring it down and change it to a positive.
All right, so the only thing you're doing is bringing the x to the -3 down and making it positive. So once again, my trick is to make the division key first. And then Abraham said, move it down, make it positive, and we're good. All right, so Fatma, what do I do with the -15 and the 5 for number 2? What operation do I do?
Divide.
Yep. So -15 divided by 5 is -3. And now since we're dividing the same bases, we're minusing the exponents. You always want to start with the numerator exponent first. So then we have -3x to the -6, and then y to the 4th. So Dua, what is the only thing that I have to move down for this one? Yep, exactly. So on the assessment, what I noticed, some of you guys try to move down the -3 to the bottom. In your case, it may have been like a -2. You got to be careful. Only the exponent that's negative gets moved down. So the -3 and the y to the 4th stays. X to the 6 goes down, becomes positive. So the check my answer is not going to work for you. I'll give you a minute to write this down. All right, does anybody need extra time on bell work number 1? Or have any questions about bell work number 1?
No.
All right, I'll give you a few more seconds. While we're waiting to move to slide number 2, if you guys could move to slide number 2, so we can get started on that very quickly. While I'm sharing my screen for number 1, for number 2, is that a growth problem or a decay problem? We're talking about cell phones.
Growth.
Yeah, it's growth. Okay. And think about, I know you guys weren't born, maybe your parents weren't even born in the 80s, but cell phones were a brand new thing. So, of course, everybody wanted to have a cell phone. You can look for the keywords increased. That's a very popular word. So, in the equation, we have to come up with our A, our R, and then tell us what the T stands for. So for bell work number 2, what is our starting value?
285.
Yeah, we started with 285 cell phones in this one town. Now, yesterday's bell work talked about moving that 75% to a decimal. What's the magic number we have to divide by?
100.
Yeah. So, Hussein, what's 75 divided by 100? Either Hussein could answer this.
0.75.
Okay, 0.75. Awesome. And then for the time, are we talking about seconds, minutes, days, years, weeks, months,
Years.
decades? Talking about years.
Yes.
Okay. So now let's put all that together. Got to have our y equals, got to have our 285. Remember, we're using the t. All right, we're good to go. Now, when it says simplify, what's the only piece that we have to simplify so far?
The parentheses.
Yeah.
Yeah, our parentheses. That's going to become our b. When you add them together, that's really symbolizes our b value. So then it's y equals 285, 1.75 raised to the t. And the cool thing here, b is greater than 1, so we know that our amount of cell phone subscribers are increasing, because here our b is 1.75. So that's just a way that you know you're doing it correctly. And then get your trusty calculator out. 285 parentheses 1.75. And what's going to go in my t value? How many years do we care about?
10.
1 or 10.
Yeah, it says use your model to predict how many cell phone subscribers were in Centerville in 10 years. So we're going to put that 10 in and then round the answer to the nearest whole number. So 7, 6, 7, 7, and then 6. All right, I'll keep my screen up for a second. So if we went over growth yesterday, what do you think we're going to do today? If we were dealing with increasing functions.
Decreasing.
Yeah, decreasing functions. Decreasing exponential functions. We call them decay. So you guys can move over to slide number 3 and read that, please. All right, thank you for the 12 of you that are. Guys, there's only 17 of you on this, and I'm not sure why. All right. All right, so what do we notice about the decay? Think about what we just did for bell work, what we did yesterday, and then look at this equation. What's the only difference?
The negative sign.
It's not really a negative. What sign is that?
It's subtraction, not addition.
Exactly.
I mean subtraction.
Subtracting, not addition. Yep, 1 minus r. So that's exactly what we're going to do today. We're just minusing r instead. And what we did before, you know, we have this y equals a times b to the t. So once again, this 1 minus r is representing our b value. And when it's decreasing, think of Donkey Kong going on that graph going down. This is what our decrease graph looks like. Our b value is going to be between 0 and 1. So give me some examples that b could be. What are some numbers between 0 and 1?
0.5.
Awesome. What else could it be?
0.6. I mean 75 or 50.
0.099.
Well, 0.99, yep, that's fine. It could be 0.758, so on and so forth, okay? As long as it falls between 0 and 1, we're good. All right, Malak, awesome. I was like, 14 new messages, yeah, okay.
Can it ever be 1, guys? Can it ever reach 1?
No.
Oh, perfect. Yeah.
Yeah. If it was 1, it would be a horizontal line, and then it wouldn't be exponential.
Yeah.
So, yeah. So I'm glad you guys noticed that. That's cool. All right, so let's get to the example. The only difference from this from yesterday is it's subtraction. So this formula is not always going to be here. You're going to need to know when to add r or minus r. And how you do that is by looking at the keywords. This says decreasing. So in your head, decreasing, all right, we're minusing. So let's get to the basics. The A, the R, and the T. So this population of 250,000 people have been decreasing by 3.5% each year. So what's our starting value?
Negative 250,000.
Did you say negative though?
What?
Did you say negative or no?
Yeah.
Okay, so all we're doing is, what is the starting value? It's just 250,000. We can't have negative population.
Oh, okay.
So the only part that we're minusing is this minus R, and that comes later in it. So the starting population is 250,000. Our rate is 3.5%. Divide that by 100. Somebody let me know what that is. All right, thank you. And then T is for years. So let's type it. Y equals 250 and then 1 minus the 0.035 raised to the t power. Now, Miss C and myself, we are begging you to actually use this calculator. You don't want to make a small mistake because you are being stubborn and not using it, okay? So for the simplify one, 1 minus the 0.035. So you have to use this whole decimal. You have to do the y equals and a 0.965. Do not round until the very end. All right, any specific questions on the two equations so far?
How do we round again?
Are you speaking for the last problem?
This problem.
Okay, I'm sorry, for the last question after 6 years.
Yeah.
So for these two steps right here for the equation, there is no rounding. You see that I have the 0.965 and then I wrote the 0.965. So we're not rounding in the middle of the problem. Now for the third one, it says, use your model to approximate what the population will be in 6 years. So where is the 6 going to go? Is it going to go in the Y or is it going to go in the T?
The T.
Yeah, exactly. So it's asking you, T is going to be 6 because we're talking about 6 years. So then we have the Y equals and let's just plug that into the calculator. And the part that's being plugged into the calculator, some of you guys made this mistake yesterday. There is no Y equals. It's just that part. So then we have 250,000. Caret key 6. Yeah, just no Y equals. Okay, because the Y equals will get you an error.
Okay, yes, Malak, but you don't put the 0. Yeah, exactly, 0.965, yeah. It's a power of 6, no Y equal.
Okay. Now, if you are struggling with rounding, you want to look at this number right here, right after the decimal. What I highlighted in blue, is that higher than 5? Is 9 higher?
Yeah.
Yep. So then you change this 4 to the next whole number, which is 5. So that's how you
What
round.
if it was 5?
You would still round up 5 or higher.
Does it have to be right after the decimal or like?
Yes. 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 So this population is decreasing. There's a couple of ways that you can look at this. All right, my B is between 0 and 1. So we know we're on the right track. We started with 250,000 people, and now we have 201,885. Is that a smaller number or a bigger number than our original?
It's bigger.
Bigger?
We started with 250, and now we're at 201.
It's
We'll
smaller.
talk about that one.
Yeah, it's
Smaller.
actually smaller. Remember, the
Decreasing.
population is decreasing. So it started with 250, and now it's going to 200.
Decreasing, yes.
Yeah. So that's a way that you can, double check as well. All right, I'm gonna open it up to slide number 5. I'm gonna keep this on my screen. Um, so you know what needs to be done. But if you guys can move on to slide number 5 to work on that problem. All right, so Hussein A, if you can move on to slide number 5, please, that would be great. All right, it looks like you guys are doing awesome. Thank you for the 15 of you that are doing this. This is great. Looks like you guys are using the calculators as well. Yazin, for the second question, you actually want to minus the 1 minus 0.14. So you want to simplify that. So you should only have one number inside the parentheses. Yep. Now, while you're doing this problem, I'm hoping that you are realizing that appliances or TVs or even cars, and the next example will be a car, it loses its value, okay? This is why you spend a fortune on a TV, and then a few years later, you try to sell it on Facebook Marketplace, and you're not getting any money for it because the value is depreciating or decreasing. All right, I'm gonna wait a couple more minutes to see if you guys can answer the second one. Yazine, if you could read the chat for me. Yeah, I'll give you guys access to slide number 6. Say what? Day 2 of not having homework? Man, you guys have the best math teachers ever.
They do.
Yeah.
So pay attention, guys, when you are working on the simplified form. I noticed that several of you forgot to put the t, the exponent. So this is a very important part of the equation. You can't forget to put it back.
Yeah, you definitely need to have the input and the output. So the input is the t. In equation, you need to have both variables. So it seemed like a lot of you guys powered through and got this correct. Like I said, please use this calculator, especially for the decimals. No one likes decimals, not even your math teacher. But when you get this 0.86, that is your B value. That is what you put. So then y equals still the $1,500.
Okay, guys, so the alarm is telling us that we still have 5 more minutes for the class to finish.
Okay, and for the third one, it says, what would be the expected value of the TV after 3 years? So where am I going to put that 3? Am I putting it in the Y or the T? Putting it in the T because that's our years.
The screen is black.
My screen is blank.
Black for me.
Just hit refresh. The internet always gets tired on Fridays.
No, I mean in the Zoom, like your screen, we're not matching you. It's black for me.
Yeah, I don't know. And then just use the calculator to plug in everything, including that raised to the 3 power. And then it says round to the nearest whole number. So after 3 years, your television is only going to be worth $954. All right, let's look at the car. See, this is why I don't believe in buying fancy cars. A lot of you guys want Land Rovers or like souped up Expeditions. After, as soon as you drive it off the lot, it loses value. A Lambo? All right. Cruise down Ford Road in a Lambo. My dog's being crazy, by the way. Ignore them. All right. So
I
this
mean,
is
the hypercars are dumb. Hypercars are dumb.
Veloster? Is that how you say it? Veloster? I have no idea what that is. What brand is that? Hyundai. Yeah, most of the cars that are very expensive are not pretty to look at. So, let's look at this. A new car that sells for $18,000 decreases 25% each year. Write a function that models this. Thank you, Ollie. My husband will be very happy. He just said Mustangs are the best car out. All right, you got a thumbs up from my husband. All right, so can somebody give me the equation that they put in for number 1?
Okay. I put y equals 18,000 parentheses 1 minus 0.25, then close parentheses, then a t.
All right, cool. Awesome.
It stays wrong for me though.
Did you put the t as an exponent?
Yeah.
Put the 0 in front. 0.25. I just did not put it as an option.
Put it. I'll put it there.
Yeah, just 0.25 and then it will work.
That's correct.
Yep.
I wrote the right equation for the second one. And then
Okay. Just don't put the 0. Just put 0.75. Yeah. Yeah, you know, with the programming, I just didn't come up with all the options today. And then what's the price after 5 years? It's going to be 4,271. Thank you. All right, guys, you are good to go. If you have any questions on this or you're not sure, virtual learning lab today.